All right, this is just a little bit of an explanation of an exclusive OR gate, not NOR or. If this was an exclusive NOR, you would see a little bubble right at this. Let me bring it up a little more. There we go. So basically on the screen right here, let's move this guy up a little bit. There we go. So on the screen right here, I have just a bunch of switches on here, and I'm going to go ahead and I'm going to switch these both low. There we go. So if they're both low, we know that if there's an odd number of ones or zeros, odd number of ones or zeros, then there's going to be a high. If there's an even number of zeros or ones, then we know that there's going to be a low. Again, if there's an odd number of ones or zeros, there will be a high. If there's an even number of ones or zeros, it's going to be a low. So if we look at this and we start it out, I'm going to put my thing right there. You put my cursor right there. So a 0 to 0, well, that tells me it should be a 0, which it is. If I go with A going 0 and B going 1, there we go, B going 1, that lights up, and there is a 1 right there. Again, if I flip the state of this, A is going 1 and B is going 0. I should have this lit up, and there's a 1 right there. And likewise, if I go with a 1 and a 1, there should be nothing in the output, and the light is off. So that explains in visual detail of what an exclusive OR gate does. Again, this is not an exclusive NOR, this is an exclusive OR. Thank you. All right, so the exclusive NOR gate, this is the 74LS266. Now, the 266 is an open collector, so we have to set up the circuit the way you actually see it right above here. So instead of using an LED, I'm just going to use this logic probe right here so you see the output. So as you can see, in an exclusive NOR gate, an even number of zeros or ones equals a high, and a odd number of ones or zeros equal a 0. So if I actually do this, so if you see, there's a 1 right there, so that's a 1. So this is an even number right here. So this should be odd because that's an odd number and that's an odd number. So 1 and a 0, just odd number right there. So that should be a 0. Let's test it out. So A is 0, B is A is 0. Yep, A is 0, and B is 1. So let's put that up. Let's get that up there. There we go. And it is 0. Likewise, that should be a 0. So I'm just going to flip these switches. There we go. And it's still a 0. Now, if I go to a high and a high, A and B are high, high, well, guess what? That goes high. That goes high. So that gives you a visual demonstration of an exclusive NOR gate, exclusive NOR gate. So if you have any questions, please feel free to outreach to me.